Okay, so independent and dependent variables. If you're like me, it can be tough to identify which one is the independent variable and which one is the dependent variable when you're first studying research methods in psychology. The dependent variable is the outcome. Whatever outcome you're measuring is your dependent variable. So if you want to know the things that contribute to or might influence creativity, your measurement of creativity, however you're measuring it, is your outcome, and that's your dependent variable. And the amount of creativity or change in creativity or whatever it is that you're measuring depends on the independent variable. So the independent variable are the things that you're varying to see whether it has an impact on the dependent variable. So if you replace the word outcome with dependent variable, if it looks like that's the outcome, that's your dependent variable. And the things that change the value of the dependent variable are those independent variables, just so that you're clear on that. Your experimental group and your control group, I've already talked about. The control group wouldn't receive the treatment. Now, sometimes you want to know whether just getting attention could be something, right? So you don't necessarily want to have the control group do nothing. If you're having an experimental group do tutoring for 8 hours over the course of a semester, you might ask your control group to do something else for 8 hours over the course of a semester. Perhaps they learn about something that's unrelated to their performance in the course. It might be something that you would learn in an ACA 122 course about transfer opportunities or the FAFSA or picking a major or an interest in something that's unrelated to the material in that class. So again, random assignment to being either in the experimental group or the control group is key to having the results of your study actually mean something. Now, there are going to be extraneous variables. There are going to be variables that influence your outcome that weren't the things that you were measuring. And so sometimes you have to control for those. Sometimes you have to measure them, even if you want to discard them, because you need to know what they are. Sometimes there are confounding variables, and it's hard to tease things apart. And again, random assignment to groups means that those errors will be randomly distributed between your control group and your experimental group, so they're unlikely to be the reason that the outcome was changed. So when you're actually doing research of your own, you'll learn a lot more about third variable problem or extraneous or confounding variables. So experimental research, the advantage is that you can identify cause and effect relationships. If you've manipulated something and that causes a change in your dependent variable, then you've shown something, and you've actually shown that there was a causal link there. The disadvantage is that experiments are usually artificial. People often know they're being studied. They act differently when they know they're being studied. So there are problems with experiments. Sometimes you're bringing them into the lab to have them do something to show empathy with other students. Well, that's great, but that just tells you about empathy in the lab. It doesn't tell you what they might do if they saw an accident or somebody who needed help out in real life. And so there are both advantages and disadvantages. You can control a lot of things in an experiment. And so being able to control those things can really be important. But research in the real world can be pretty messy sometimes. I've got a video that I want to show the next time we meet in class. It's not the one that's associated with an assignment, but it's the same subject matter, which is a marshmallow test. But I'm going to hold off on that and show it to you another time. Correlations. So correlations, here's where remembering absolute values in math can be really handy. A correlation can vary between 1 and -1. And so 0 is right in the middle, and a positive correlation would be somewhere between 0 and 1. And a negative correlation would be somewhere between 0 and -1. The reason that I said absolute value is the strength of a correlation tells you how much predictability you have. So if I know that two things are related, but it's kind of messy and it doesn't really tell me a whole lot about outcomes, then it's closer to 0. But if I know that two things are related and when one changes, the other one almost always changes, well, then that's going to be closer to 1. 1 is a perfect correlation. A perfect correlation would say every time there's a 1 unit increase in this variable, there's also a 1 unit increase or decrease in this other variable. Now, increase or decrease is important. When you talk about correlations being positive or negative, it isn't the same use of positive and negative that you might see in your everyday life. So a positive correlation means both variables are going up at the same time. As one goes up, the other one goes up. It can also be a positive correlation if, as one comes down, the other one comes down. A positive correlation means that both variables are heading in the same direction. So the example on the screen is height and weight. As height goes up, especially early in life, weight goes up. And so there's a positive correlation. If it was a perfect correlation, for every 1 unit of height, there was 1 unit of weight, then it would be a straight line. But that's not true. Sometimes you get a little bit taller and you gain some weight, but not as much weight as somebody else. And so it's not quite a straight line, but you can definitely see the trend there. So that's a positive correlation. Tiredness is, they're showing you a negative correlation. And it isn't just that the dots are going down, but think about how those variables are being measured. Hours of sleep. As hours of sleep go up, then tiredness should go down, right? So they're going in opposite directions. So as the hours of sleep go up, tiredness goes down. As tiredness goes up, hours of sleep may go down. That would be a negative correlation. And then hours of sleep and shoe size, no relationship at all. And so the dots are all over the map. So think about that in terms of how you think about correlations. I like this chart better than the other one, so I would say ignore that other one. A positive correlation. High school GPA and college GPA are closely related. It's not a perfect correlation, but if I know your high school GPA, I can predict with some degree of accuracy, not perfect accuracy, what your college GPA will be in a group sense. Like for an individual, it's pretty hard to do, but all the people that came in with a high school GPA of 4.0 and higher or 1.5 and lower, you can predict what their college GPA might be based on that. High school GPA and college GPA can go down together. So as high school GPA goes down, college GPA goes down. As high school GPA goes up, college GPA goes up. So those are positive correlations. Whether they're going up or down doesn't matter. It's that they're going in the same direction. I mean, it does for GPA, but for the purpose of identifying whether it's a positive or negative correlation. In a negative correlation, they're going in opposite directions. So as absences from class go up, exam scores go down. As absences from class go down, exam scores go up. So that's a negative correlation because they're going in the opposite direction. I'm moving my hands too much. So keep that in mind when you're thinking about correlations. This is something that I've used in class before. When you think about if people are more, say people are more outgoing, they are also more, and then I'll let you fill in the blank. So I would suggest pausing the video here and trying to answer all of these questions because that's going to tell you when you have your own examples and then you identify whether that's a positive or a negative correlation, and then we can talk about it in class, then you'll be able to internalize the difference between a positive correlation and a negative correlation. So newsflash, more and more or less and less should both be positive correlations because they're going in the same direction. There's more of this and more of that, less of this and less of that. But once you get more and less or less and more, they're going in opposite directions. And so that's a negative correlation. And then the last two, if they're more of something, say more extroverted or more conscientious or empathetic or whatever it is that you wanted to measure, could be either more or less. What that means is knowing that first variable doesn't tell you anything about the second one. And that is that's a correlation, that's a very weak correlation, or the variables might not be correlated. The correlation coefficient, just to wrap that up, varies between 1 and -1 and any number in between. So it could be a -0.68, it could be a positive 0.68, positive 0.86. Those are relatively strong correlations. They're not perfect because they're not 1, but they, knowing the value of GPA in high school tells you a lot about GPA in college. Knowing height tells you something about weight. The closer they are to 0, the more you really have no idea. It doesn't tell you anything. GPA doesn't tell them anything about shoe size. So that's how that goes. Correlation does not equal causation. We've talked about this before, and we will continue to talk about it throughout the semester. It'll be on the next test. It'll be on the final exam. And you hear it way too often, but it's true. Knowing that two variables are correlated does not tell you that one caused the other. High school GPA does not cause college GPA. High school GPA is related. Something else is causing both of those things. And so you need research to understand what those relationships are. As ice cream sales go up, so does crime and murder in urban cities. So Is ice cream causing murder? Clearly not. Is murder causing people to eat ice cream? Clearly not. But hot weather can increase both of those variables. And so that would be that third variable that you didn't necessarily measure that was impacting both of those things. The result of the last NFL game in the Washington football team, so the Commanders, before the U.S. presidential election, accurately predicted every election result from 1936 to 2000. So, again, that's sort of a spurious correlation, right? Clearly, football does not influence in and of itself an election outcome, a presidential election outcome. And then alcohol consumption is associated with an increased risk for lung cancer. Alcohol doesn't cause lung cancer, but people who drink excessive amounts of alcohol are also more likely, probably, than people who don't to smoke. It doesn't mean that every person who drinks alcohol smokes, clearly, but on balance, if you don't drink alcohol, you might also be a person who doesn't smoke. And so that's where the correlation with lung cancer might come in. So different ways of measuring things. A naturalistic observation, you just go out and measure what's happening in the real world. If you want to know how kids treat each other and whether they are nice to each other on the playground, go out to a playground and watch them. That's a naturalistic observation. You're going to see a lot of things. You're going to have a pretty good list of what you're looking for. What would you consider a pro-social behavior versus an antisocial behavior? When is it aggression? When is it just roughhousing and playing? So a naturalistic observation can be a good way to do things, but there's going to be a lot of messiness out there. You can't necessarily control who's going to be there, and you have to do a lot of watching. Case studies are typically used when there's one person of interest or there's one case that's very interesting that seems to illuminate something that we couldn't have known otherwise. Case studies sometimes are because somebody was injured, somebody was abused, somebody has a psychological disorder. That's not the only reason for a case study, but when I think of famous case studies, sometimes it will be, like I know the case study of a young woman or she's not young anymore, named Jeannie, who was discovered at 13 and had been severely abused her entire life to the age of 13, had not been spoken to and had been kept in isolation. So that's a case study. It doesn't happen to very many children, fortunately. But it's an interesting case because people who are interested in psycholinguistics wanted to know, could she acquire language at 13 when she had never had any language? This was not a second language for her. She didn't have any spoken language. Is there a critical period where if you don't learn language by a certain age, you're not going to be able to learn it? And that was a strong test of the critical period hypothesis. But it was just one person, right? And so there could have been other reasons for the outcomes that they found in her case. And that's where it's highly subjective. It's just one person. But it can illuminate things. Somebody with a brain tumor in one area of the brain, and we'll talk about this in chapter 3, might be able to tell us something about what the function of that area of the brain is. We don't go around damaging people's brains just for the fun of it, but we can do what we call a natural experiment and see what happened when that area that we knew about had been damaged because of illness or injury. Surveys, you've taken lots of surveys. Self-report data, you know yourself the best. And so if I want to know about your personality, I should ask you. I can watch you, but I don't know what's going on inside of you. So surveys can be super helpful, but also you might not want to tell me for any number of reasons. If I ask students, like, how much do you use AI? And what percent of your written assignments did you use AI, 100% for, or partially for, or not at all? I can ask, but since I'm the instructor, a student might not want to answer in a way that might impact their grade. And so there are all kinds of reasons why people don't answer surveys. If you're taking a questionnaire as part of an employment an onboarding packet or a hiring packet, they're trying to decide whether to hire you, you might want to be careful what you say or how you answer those questions. And so surveys can be super helpful, but they also have their own problems.